Hello and welcome to Algebra 2 tutorial. In this video we're going to take a look at writing the equation of a trigonometric function from a graph, a table, and a modeling problem. So we're going to have to identify the amplitude, the period, the midline, the phase shift, all of those, like I said, from a graph, a table, and a modeling problem. So first, let's do this from a graph. So we've got ourselves a wave here. It could be either sine or cosine. And we're going to actually write an equation as both, I believe. So first we have to identify the amplitude, the period, the midline, all of that. So amplitude, period, midline, and we probably will even use a phase shift, but that is sometimes optional depending on what type of function you have and what kind of equation you want to write. So first, amplitude and midline go together. We need to find the middle and then what the amplitude is. Now this one I made the numbers not work out so well, so you can't actually eyeball it. The middle is somewhere in here, and then we're going to have to find the amplitude going up and going down. So what we have to do to find the middle, so the middle of any numbers is just the average. You're going to take the biggest and the smallest and average those two numbers, divide by 2. So our midline, the biggest is 8.2, the smallest is 2.8, and then we are going to divide by 2. This isn't too bad, so when you add those you get 13. 11 actually. You can always just do that on your calculator. 11 divided by 2, and so our middle is 5.5. So our midline is the horizontal line y equals 5.5. And hopefully that definitely checks out here. This looks like 5.5 right here. So there is our midline. Now that we have the midline, we can find the amplitude. So the amplitude is the distance from that middle all the way to the top, or for the distance from the middle all the way to the bottom. So we have to just take this top value, 8.2, and subtract the middle value, the 5.5. So for the amplitude, you take the top minus the middle. Now that would also be the same as the middle minus the bottom, same thing. So we are going to take the top, which is 8.2 minus 5.5, and so that is 2.7. So our amplitude is 2.7. Now it's time for the period. So we have to take a look at how long is one wave. We have a couple of places we can measure from. I might just start from here, top to top. So that distance there is from 0 to 4, it looks like. So our period is 4. Now remember, that number does not go in the equation. All right, our equation period is equal to 2 pi over b. The b value is what goes in the equation, and the period is what you see from the graph. So we'll solve that equation here. Period is 4 equals 2 pi over b. So we need to solve that equation for b. So you're going to multiply b to the other side. So you'll have 4b is equal to 2 pi. Divide both sides by 4. So that goes away, and b is equal to, you reduce this and you get pi over 2. All right, we have all of our characteristics. Now we can write this equation. So I'm going to first write the most basic equation that starts right here. All right, so there's no phase shift with that equation. So that will be y equals, my amplitude is 2.7, It's starting at the top of the wave, so this is going to be described by cosine. And because it also is at the top of the wave, it is a positive cosine, times my b value, which is pi over 2, x. There is no phase shift, so nothing goes inside those parentheses. And then my midline is 5.5, so plus 5.5. So there's our completed equation. Now that's not the only option we could do. We could also take this and write it as if this were our starting point. So we're actually going to add a phase shift here. This is going 2 units to the right. So when we're going to write that equation, y equals, the amplitude is still 2.7. We're at the bottom of the wave, so this will be a cosine still. But because that cosine is starting at the bottom, it's been reflected, so it is a negative cosine. The period didn't change, so the b value doesn't change, so that's still pi over 2. But now we have a phase shift. We move to the right, so we minus the 2, which is how far to the right we moved, plus 5.5. So there's actually many options for equations that you can do here. Those are just 2 of them. So if you put those into a graphing calculator, you would get this exact same wave for both of them. All right, so that is how you can take a graph and turn it into an equation. Now we're going to do the same thing, but we're going to start with a table and again turn it into an equation. So here I've got a table this time of x and y values. And we will figure this out. Again, we need all our characteristics. The amplitude, the period, the midline, and if we want a phase shift, we could write an equation with a phase shift as well. Alright, so let's take a look here. We need to know where the top, the bottom, and the middle are. So this wave is going from 8 down to 4, back up to 8, up to 12, back to 8. So it's looking like 8 is the middle, 4 is the bottom, 8 is back to the middle, 12 is the top, and 8 is back down to the middle. So that gets us most of what we need. The middle numbers are the midline, so that is y equals 8. The amplitude is the distance from the middle to the bottom, which there you can see it's 4, or from the middle to the top, which is also 4. So that was a little bit easier. We didn't have to do any subtractions. Now the period, though. What is this period? So we're going from the middle to the bottom to the middle to the top. Well, if I look at the bottom to the top, we should be able to recognize that as half a wave. If I draw that from the bottom to the top, that is only half a wave. We would have to then do the other half to get one full period. So if I take that distance there, that is half a wave, and so I'll double it to get a full wave. So the distance from 5 to 13, remember we're looking at x values because we are looking at the horizontal distance. You want the x values, not the y values. So that distance right there is 8. That was only half the wave. If that distance is 8, this other distance is also 8. So my period is a total of 16. All right, let's start putting this into an equation here. So y equals, my amplitude is 4. And so now we have to decide, are we going to make this a sine or a cosine wave? We haven't done a sine yet, so let's do a sine wave. So that means sine is starting in the middle. And so that will be starting one of the middles here. We can just do this one. So it's starting in the middle, and then we go down to 4. Well, that means sine has been reflected because it's starting in the middle and going down. Sine usually starts in the middle and then goes up. Let's see. Oh, I've kind of neglected my b value, haven't I? So I don't know that part yet. But I do know this will be x minus, if this was my starting point, I went over 1. So that'll be x minus 1. And the middle is plus 8. So hopefully you can see most of that is easy. The one thing we have to do some work for is the period. So remember, our period equation is period is equal to 2 pi over b. So my period in this case is 16. Multiply the b over. So it's 16b is equal to 2 pi. Divide both sides by 16. And b is equal to, that reduces to pi over 8. So that is the number that goes in the equation, pi over 8. So there is our completed equation to go from a table to an equation. You have to find the middles, the bottoms, the middles, the tops, and then you can identify your characteristics. All right, last topic here. So we're going to take those two and sort of put them together and look at a modeling problem. And so I found some data here. This is the average temperature of, I believe it was Tokyo. Every week they would average the temperatures. Wolfram Alpha can give you this. It's actually quite cool. So we're going to model this wave and write an equation that would model that. So just like last time, we need the bottom and the top of this wave. So my maximum temperature that it looks like this wave is doing, let's see, that's 90. We're getting up to here. So I would say I'd call that 85, I think. And the minimum, what is our lowest here? That's 50, so that's 40. I would call that 40 as a minimum. So because I know the max and the min, I should be able to find the middle. So remember, the middle is you take the biggest plus the smallest and divide by 2. And that gives us 62.5. All right, once we have the middle, we can find the amplitude by taking the top minus the middle. So 85 minus 62.5 gives us 22.5. So we know the amplitude, we know the midline. Now let's do the period. So what is the period of this data? Well, bottom to bottom, to bottom, to bottom. It looks like the lowest temperatures are always happening at the beginning of the year. Hey, January is winter. So every winter happens once a year, so our period is 1 year. Now again, that does not go in the equation. So we do period, which is 1, is equal to 2 pi over b. Multiply the b over, and b times 1 is just b, so b is equal to 2 pi. All right, we're ready for our equation. So y equals, my amplitude is, let me put this a bit more front and center for us. I'll make it bigger. Y equals, amplitude is 22.5. Now, sine or cosine, which one do we want to do? Well, this is real data that goes on forever, so we kind of need to pick a 0. So let's call the y-axis this one right here. Well, I'll change my mind though. Let's make year 0, 0. All right, and if I want to make this my starting point, then that is going to be a negative cosine of, my b value is 2 pi, x minus, well, if I want 0 to be 0, this starting point is at 2015. So that is x minus 2015. Let's make those square brackets. And then my midline is plus 62.5. So there we have it. That is the equation of that graph. All right, so we've been writing lots of equations here. Again, we did it in 3 different ways. From a graph, you still have to identify the amplitude, period, midline, phase shift. From a table, you still have to identify amplitude, period, midline, phase shift. And the same thing from a modeling problem. You need all 4 of those characteristics. All right, here's one for you to try. Good luck.